Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of object-oriented software engineering. We'll dive into key concepts like illustrative case studies, like ATM, Payroll, course and registration system. Let's get started. Slide 1. Illustrative case studies. Today, we will explore how object-oriented software engineering (OOSE) is applied in real-world scenarios. Case studies help us understand software design practically by analyzing real-world systems using object-oriented (O) principles like encapsulation, inheritance, and polymorphism. The three case studies we'll discuss are the ATM system, payroll system, and course registration system. Each of these involves designing classes, relationships, and behaviors to create efficient and scalable software. For instance, in an ATM system, when you withdraw cash, different objects interact, such as the ATM machine, the bank account, and your debit card. These objects have specific responsibilities, and their interactions are managed using OO concepts. Slide 2. Case Study 1 ATM System. An automated teller machine, ATM, is a common example of software designed using OO principles. The system allows users to perform secure transactions, such as withdrawing or depositing money and checking their balance. Key objects and responsibilities: user, the person using the ATM. Card, authenticates the user before transactions. Account, stores details about the user's bank balance. Transaction, manages different operations like deposit and withdrawal. Now, let's look at how object-oriented principles apply here. Encapsulation, the user cannot directly access or modify account balance, they must go through the ATM interface. Polymorphism, different types of accounts, savings, checking, behave differently, yet they share a common structure. Inheritance, the bank account class may have subclasses like savings account and current account, inheriting common attributes but modifying specific behaviors. By designing an ATM system in an OO way, we ensure that the system is modular, reusable, and easy to maintain. If we need to add a new feature, such as mobile banking, we can extend the existing classes rather than rewriting the entire system. Slide 3. Case Study 2 Payroll System. A payroll system automates salary calculations, ensuring accuracy and efficiency in processing payments. This is critical in organizations with many employees. Key objects and responsibilities: employee, contains information like name, ID, and salary. Department, groups employees and maintains budgets. Payroll, calculates salary based on working hours, deductions, and bonuses. Bank, handles salary transactions to employee accounts. Now, let's relate the system to object-oriented principles. Encapsulation, employee salary details and tax deductions are private, only accessible through authorized payroll processes. Inheritance, employees can be full-time, part-time, or contractual, inheriting common attributes from a base employee class. Abstraction, employees don't see how tax and deductions are calculated, only the final salary amount is displayed. By using object-oriented design, the payroll system becomes scalable and easy to modify. For example, if tax laws change, only the payroll class needs an update rather than modifying the entire system. Slide 4. Case Study 3 Course and Registration System. The course registration system allows students to enroll in courses, track their schedules, and manage academic records. Key objects and responsibilities: student, registers and selects courses. Course, contains information like course name, schedule, and instructor. Instructor, teaches courses and grades students. Registration, manages student enrollments and prerequisite checking. Now, let's analyze the system using object-oriented concepts. Encapsulation, Student academic records are private and can only be accessed through authentication. Polymorphism. Different users, students, instructors, and admins interact with the system differently. Association. There is a many-to-many relationship between students and courses, as one student can register for multiple courses and one course can have multiple students. This object-oriented design ensures flexibility and allows for easy integration with other academic systems, such as attendance tracking and online exams.